Hi, so this is the spreadsheet I have for the Conservation of Energy lab. As you can see up here, it's a ball drop lab, so we're going to have the probe wear set up a couple meters, and then we're going to drop a ball underneath it and measure how it falls, what its velocity position as it falls. And those are going to be recorded in a table such as this, and then we're going to use that to extrapolate the potential energy and kinetic energy over in a table such as this. And this right here is actually the theoretical calculation. So part of the lab, they're going to at this point, they've already been exposed to calculating potentially kinetic energy, and they're going to use that information to see what they should expect. They also have already been exposed to the conservation of energy at this point, and this is the lab to confirm the conservation of energy. So they're going to do the ball drop, record their data. Oh, sorry. First, they're going to do a theoretical calculation. So they're going to, take the time, have the height decrease as time goes on, and calculate what the height would be, and then calculate what the velocity would be, and then use that to calculate the theoretical potential energy and kinetic energy. And then one thing they're going to do is they're going to make graphs of that, and you can see that right here, where you have position and height. Position height versus time, position velocity versus time, and then over here, potential and kinetic energy versus time. And you can see, and they'll be able to see, once they have the graph in front of them, just how potential and kinetic energy changes over time, and how one replaces the other, but the total energy always stays the same. Okay, and then they get on to the actual experiment. So these are going to be the actual recorded results. And so these are measured ones. You have time, position, velocity. This is what the probe wear would record. And then time, potential versus kinetic. This is the extrapolation of potential and kinetic energy given these position and velocity inputs. And I don't know if you can see, if I click on this guy, you can see the equation up here. This is a slightly more advanced spreadsheet technique that you can use in Excel. And I know, for instance, in the class that I've been observing, most of the people in the Regents class, the Regents physics class, don't know how to do this sort of manipulation in Excel. And this, I feel, would be a good opportunity to teach them how to do that, because then they could, instead of having to input each data, they could do the one equation and then click and drag all the way down and get results for all of their data points without having to type it in and do the calculation by hand every time. Just a really useful Excel mechanism to know. And then you can see they would put in the data. One thing that I haven't included in the spreadsheet that I would include are error bars, because as with any measuring device, the probe wear is going to have a certain amount of error associated with it. And so that error is going to go in here and then be extrapolated over into the calculations of potential and kinetic energy. And yeah, so I'll include error bars and teach them a bit more about Excel and how to use Excel, how to make more relevant graphs where you can really see the data. And yeah, that's about it. Thank you very much. Bye-bye.